I am in Moodle right now, and I'm going to start off with predicting the range at 20 degrees. And I'm just going to select my initial velocity file, and I just want to download that. Oh my gosh, I don't want to do that. So it's already in my Dropbox, so what I'll do is I'm just going to go to my Dropbox and get that. So you would want to take it over to your Dropbox, of course, and then download it. So I'm just going to go to initial velocity, I believe that's it, and then I believe it's projectile motion. And I believe it was a Saturday class, but I'm going to start off with this one, okay? So I'm just going to bring this in. I'm just going to open this in Microsoft Excel. So it's asking me to duplicate it. I'm just going to go ahead and duplicate it, and I'm going to say that this is for Saturday day class example, and that'll be fine. And I'll still put it in my initial velocity and projectile motion, I believe that was it, file. So it at least allows me to duplicate it, and we have our initial velocity here. So what do we want to do first? Well, we want to predict the range. So let's just start up a new sheet, and let's call it predicting the range. So we're going to start off with our initial velocity here. Okay, and that is going to be in meters per second, of course. It's going to come from the other page. And so let's wrap this. And I'm just going to go ahead and say equals to this value here. So we know that it's just equal to this initial velocity, which is fine. And I can go ahead and change my formatting. And after that, we're just going to go ahead and put in our angle in degrees. So that didn't look like it really worked well. So we know that that's angle in degrees. The first one is just going to be 0 degrees. Of course, I'm just going to continue to format it so it can look fairly decent. Probably can do that all the way across. And just say wrap and center and middle. And then we want our angle in radians. Angle in radians. All right, so just go ahead and hit return. So we know that this is going to equal to our angle in degrees times pi, just pi, and there's our function, divided by 180. So we should have received 0 there. That's fine. And then after the angle in degrees is taken care of and the angle in radians is taken care of, the very next thing that we want to work on is calculating the time of flight. So the time of flight is going to come from a quadratic equation, and let me see if I can pull that quadratic equation in for you. All right, so let me go ahead and close this. And that was a Saturday day class. Predicting the range is here. So this was our equation, right here. And we are going to use this time equation, or this time solution. We have a negative b plus or minus the square root of that quantity divided by what you see here. So I'm just going to slide over. So the first thing we need is b, and I'm just going to put b in here. Lowercase b. And then, and why b? No, let's start off with a. Lowercase a, and then lowercase b, and then lowercase c. So a, if I go back, you'll see that a is just 1/2 g here. So, and it's a negative 1/2 g. So I'll just say equals to a negative 1/2 times 9.81. It gives me that value. And then b is, if I just slide over, it's v naught sine theta. So we have our initial velocity. So that means this is going to equal to our initial velocity times sine of the angle. And the angle needs to be in radians. And we have that already right here. And so I can just say return. So basically we fired the ball out straight at 0 degrees, so there was no velocity in the y direction. And then c is just going to be a reference back to our initial velocity, and the average displacement in the y direction is here. So that is what c is. It's just the average velocity. And not average velocity, it's just the average, let me go back. It's the average displacement in the y direction. So we have all of this information. Now the big thing about this is if we go back to this sheet here, just go ahead and throw this away. You'll see that we have a negative sign for the c. So we have a negative yf minus y naught. So I need to actually put a negative sign in front of this. So there we go. So it's going to turn it to be positive. It's going to make it positive. Now we can calculate our time of flight. So I'm just going to put in time, and we know that this is going to be in seconds. Okay. And our time of flight is just going to be, let's see here, get rid of that. It is just going to be this equation down here at the bottom, this formula, b, negative b plus or minus square root of b squared minus 4ac divided by 2a. So let's go ahead and put that in. We're not going to use the plus, we're just going to use the minus sign. And it's because I know that the plus is negative. You can try it out yourself, but I know that the plus is negative. So we're going to use one parenthetical statement, minus b minus the square root, sqrt, of b squared, b squared minus 4a times c. I don't know what just happened there. Let me do it again. Negative b. I'm in the wrong location altogether. Oh, there we go. So 4 times a times c. So all of that is in the numerator. Now we need to put our denominator in, and that's just going to be 2 times a. Still 2 times a, and we're going to close that statement. And this is giving us our time. So we feel like we're on the right track because our time was over here as well. We calculated it a slightly different way, but it's giving us the same value, so that's kind of cool, at least as far as a check goes. It does somewhat of a decent thing. Now we want to predict our range. And we kind of know what our range should be. It should be about 3.96 because we've already done this. So the range in meters is going to be equal to the initial velocity times cosine of the angle at 0 degrees times time, the time of flight. All right, so we see what we're getting there. We're getting 0.395, and that is what we have literally over here. If we just rounded it down to 3 decimal places, that's what we would get. So this is letting us know that we have a pretty good check there. So this is going to be our predicted range. Predicted range, and then we're going to have our measured range over here. Measured range in meters. So we know what this is. We can just say equals to, go back here and get our measured range, and then we have our measured range in meters. And let's, of course, make this an appropriate number. And so in the next video, we're going to look at producing the percent difference. So we can look at that, and then we're going to actually do something similar when it comes to an angle at 20 degrees. Okay?